Hey, what's up, guys? This is Chung here again. So this time, LeetCode number 1882, right? Process tasks using servers. Um, so this one, is a pretty long description problem, right? So basically, you're given like two zero index integers. So first one is a server. We have a bunch of servers, and then we have a bunch of tasks. Okay, and the servers has a weight on it for each one of them. And the task j is the time needed to process j's task in seconds, right? And then we have several rules to assign the task to a server, right? So basically, you're running a simulation system that will shut down after all the tasks are processed. And so basically, uh, first thing, one server can only process one task at a time. And so when you try to assign a task to a server, right? So let's say there's like multiple servers available. Basically, you will just pick the server who has the smallest weight. Okay, and in case there's a tie, right? So in case there's a tie, and then we always pick the ones with a smaller index, right? And that's that. And after you assign a task to a server, basically that server will be free again at the time of the t, the current time plus the tasks, right? So if there are no servers, free servers, basically you have to wait until the first server be available, and then you can assign, and then you will use that server, right, to process the current task. And our goal is just to output like array where each element is a server that who will be processing this task, right? So for example, in exam in example one here we have three servers, right? And each server has a like kind of weight, right? And then we have like six tasks, and so we have output is like this, which means that for task one, for task zero, or we'll be using server two because at the beginning, right, all the servers are available, right? And then since server 2 has the smallest weight, that's why will pick that. And then on time 1 here, right? And I mean, basically, server 2 will become available again. That's why we pick 2 again, right? And then as for the task 3 here, server 2 is still processing the the task 1. That's why we'll pick the server 0, right? And then so on and so forth, right? Cool. So and there are like some standard constraints, 10 to the power of 5, right? Obviously, so for this problem, in order to simulate this process, we need to use like some the priority queue, right? So basically, we need two priority queues. So the first priority queue will be the idle ones, where you can call it available servers, right? And then the second one is the running servers, right? And and at each of the tasks here, right? Basically, we'll first check if we'll use the current time, try to free some tasks from the running servers, right? Basically, if there are running servers available, then we'll basically put them back into the idle ones, right? And then if there's an idle one, we always pick the idle servers who has the smallest weight, right? And then of course, besides weight, we also need to put the index along with the weight so that it can be sorted properly, right? And I think the tricky part is a little bit tricky part is that if at the current task here, right? If there's no idle one, right? So if the idle one is empty, which means that all the servers are running, right? All the servers are running. Then for the current task, we don't have any servers to who can process this one. So what should we do, right? Basically, we'll need to wait, right? So we'll need to wait for the first server to be available, right? But a tricky part for this running one is that and at the beginning, I was only putting the end time and the index in here. So basically, when we are trying to free the running ones, of course we'll be using the end time, right? And then for the end time, if there's a tie for the end time, I was thinking about, okay, so if they're all uh if they have the same ending time, then I'll set the second sorting will be the index, right? But actually there is like more than that. Between the ending time and I here, we should add a wait here, because let's say if there are like multiple running servers that will be ending at the same time, which one we should pick first. Let's say there's a task, right? So the ending time is 10, right? And then the index, this one is like let's say there are like two running servers. They will both be ending at 10, and so one wait is 5, and the index uh, index is 2. The other one, the wait is 7, and the index is 1, right? So if there are these two running servers, and both will be ending at 10. So for the current task, right? So which one will the current task be assigned to? So obviously it's this one, right? Because at time 10, right? Even though let's say the current task is 5, the time is 7, right? So which means that at the current time there's no available servers, but at time 10 both servers will become available, right? And if both of them becomes available, which one we should use? Of course, it's the one with the smaller weight. And if this weight are the same, then we will basically check the index. That's why when we are storing the running servers, in order for us to get the correct next available idle servers, we should sort by 3 things instead of 2. So which is the end time, the weight, and the index. And that's it, right? Because because for the task here, actually, if the current task there's no idle servers, we don't have to wait. Basically, we know that since the first running server who will become to available will be assigned to the current task, right? And so we can just simply just use that server to assign to the current task, and then we update the ending time to the new one, right? Cool. So that's it. All right. And like I said, we need two arrays, right? Idle and running. Both of them will be the priority queue, right? So at the beginning, we will do this enumerate because all the servers will be idle, okay? And then heap push, right, of idle. The key for the idle ones is pretty straightforward. We just need wait and I because we don't need the time related, right? So we just have wait and I. And then we have the answer equal to 0. Sorry, empty. So for I and T enumerate, task, right? Well, actually, this I, this one is like it's a current time, right? So when current time, and this one it's like the duration, right? So is it current duration? Yeah, maybe this one is better. So time and duration. So at the beginning, we tried basically move move servers, right, are free now, right, from running to idle. So which means, while running, it's not empty, and running dot zero dot zero, because the running, since we're using priority queue, the first one is always the one that ends the earliest, right? Current time, right? So we do we have wait, right? So I think the time doesn't really matter. So we have wait, and then we have the server index. Okay, it's going to be a heap pop of running, and then we just we push them into the idle one, right? Because those are the servers that become available again at the current time. It's going to be idle. So and it's going to be the wait and the server index. Okay, let's just call it I. Yeah, I think we can just call it I here. And now, if the idle is not empty, right, then we know we'll just simply choose the ones from the idle, from the first one. The idle is going to be a heap pop, right, and then idle. Of course, we're going to append this one to the answer, right, and then so for this one got popped out from the idle one. Obviously, we need to move this one into the running priority queue, right? It's going to be heap push running. So the new ending time for this one is what? Is the current time plus the duration, right? So that's the new ending time for this server. And we have a wait, right? Then we need a wait for this server, which is we have the servers dot I, right? That's the wait for the server, and of course the I itself, since we need both three to be sorting. To sort this this server, the running server. Else, right? Else means that we'll just use, and then we'll wait for the first running server to be available, which is the we have the end time, right? And then we have a wait, and then we have an index, right? So that's going to be the first server becomes available, which is which will be the one from the running priority queue, right? And again, we're gonna append this one to I, and then we'll be pushing this one back, right? Since the moment this one become to an idle, we'll immediately assign this idle one to this current task, which means there's no need to put this one back to idle, right? So we can simply push it back to running, which is going to be the new ending time, which is the end time, the previously end time, right? Plus the duration, right? And then again, it's going to be the wait and I. So that's it. All right. So let me run the code here. Awkward. Obviously, there's a mistake here. Let's see. This one equals smaller, not greater, right? Yeah, now it's right. All right, cool. So it passed. Yeah. So the time complexity obviously is n log n, right? Because because we have an n here, and then here we have a while loop, right? But let me see. So here, even though it seems like we have a while loop here, but the worst case scenario. So let's say if there's only one task who'll be processing all the sorry, let's say there's only one server who'll be processing all the tasks. So in that case, there'll only be a of one time of this while loop here, because every time we'll be popping that one server out, right? And then we'll add it back, and then we pop it out and add it back, right? So if we have multiple here while loop here, then it will not be like O of n time. So we'll push this one. There are several running tasks here, and it will only be processing this while loop once in a while, you know, not every time basically. That's why we can assume this one into O of 1, I believe, right? So that's why the total time complexity is still n log n. Yeah, I think that's it, right? I mean, it's a it's a very obvious like priority queue or heap problem, and we just need to maintain two heap, right? One for idle, one for running. The only place we need to be careful is that when we push this the servers to the running heap, we need to maintain three things instead of two. This will guarantee us we'll always get the correct next available server to process the current task. Right? Cool. I think that's it. And thank you for watching this video, guys. And stay tuned. See you guys soon. Bye bye.